Hello. Today we're going to go over absolute value and how to use them in expressions. So today's goal is to learn how to use absolute value. Absolute value of a number is the distance from zero on a number line. So it doesn't really care about positive or minus. It's more of just its unit. So absolute variable. For any real number x, if x is positive or 0, then the absolute value of x is x. If x is negative, then the absolute value of x is the opposite of x. For any real number x, absolute x equals x if x is greater than or equal to 0. And the absolute x is equal to negative x if x is less than 0. And the example they give us, if x equals 12, then absolute x equals 12. If x equals negative 7, then absolute x equals negative 7, which is 7. I don't know why they have a negative here. I think they're multiplying to show you it's the opposite by using the oh no. Huh. Should just be able to remove it. Oh well. You do times by -1 to get its opposite though. Another one I like to use, we'll do it over here. So the absolute value of 10 is 10. The absolute value of -10 is 10. Easiest way I remember it. All right, example 1, write the absolute value expression. The accuracy of a meat thermometer is the positive difference between the temperature reading on the thermometer T and the actual temperature of the meat M. Complete the statement about which expressions are and are not equivalent to the accuracy of a meat thermometer. All right, so we're looking for a positive difference. What we know, absolute value only spits out a positive number. So we are looking for the difference inside the absolute value symbol. For number 1, we have m minus t. The expression, this will be equivalent, is equivalent to the accuracy of a meat thermometer because it represents the difference between the measurements, and it's always positive because it is the absolute value. If writing absolute value is a little much, an abbreviation you can use is ABS.V. 2. Unfortunately, this is the difference of absolute m and absolute t. It's not the absolute of the difference, so it does not work. The expression is not equivalent. And the reasoning is, if t in this is bigger than m minus t is going to be negative. Right here, we have the absolute value of the difference between the temperature and the meat. This is still the absolute value of the difference between them. So this will be equivalent. It represents difference between the measurements. That's what we're looking for. It's the difference inside absolute value. And it is positive because it is the absolute, so ABS, value of the difference. And our last one, absolute T minus absolute M, it's kind of just like this one. It's not going to work. If our value of M is a positive value that's bigger than T, it spits out a negative. So this expression is not equivalent. Because if M is greater than T, then absolute T minus M is negative. Really, this is interesting. It says interpreting negative x. Do not read negative x as negative x, but as the opposite of x, because x represents a negative number whenever x is less than 0. The expression negative x represents a positive number. Huh. That's interesting, but when we put the negative, it is negative. That's assigning 2 words to the symbol. Maybe that might get a little bit confusing. Think about it. Is the expression negative x always a negative value? No. If not, for what values of x is negative x positive? I know it just told me to call it opposite of x, but I don't like that. We're going to call it negative. So, well, if we plug in any number less than 0, it'll spit out a positive value. So the way to think about it is we have some function of x such that it is negative x. What do we put in? If we plug in all x values less than 0. So any value less than 0, which is a negative number, when you put it in, the 2 negatives become a positive, and we're done. And think about it. It asks us for absolute c plus d is not equal to absolute c plus absolute d. Give 3 pairs of values for c and d, which this is not the case. All right. Well, first one we could do, let's do 2 and 3. Yeah, let's do negative 2 and 3. So when we do this, this one becomes the absolute of negative 1, and this one becomes 2 plus 3. The absolute of negative 1 is positive 1. 2 plus 3 is 5. So any combination to make this not work involves us using one positive and one negative number. Because we see if we put them here, this will create a difference. If we do it over here, it won't matter. It'll turn any negatives positive. So we can pick some other values. We could do negative 1 and positive 1. If we plug that in, this one becomes 0, this one becomes 2. And for our third set, let's just say negative 2 and positive. Negative 2 and, yeah, negative 2 and 0. That's a fun one. If we do negative 2 and 0, we'll get 2. Oh, no, that won't work. Let's do negative 2 and 8. This one gives us 6. This one gives us 10. Amusement parks. At the amusement park, a vendor attempts to guess a person's weight if they are not within 3 pounds. So the person will win a prize. All right, so that means their guess can be plus or minus 3 pounds. Got it. If a person weighs 180 pounds, so if it's plus or minus 3, that means the absolute value should be 3. The absolute value of the difference is what we're looking for. ABS of the difference. If a person weighs 160 pounds, 168 pounds, and the vendor makes a guess of X pounds, all right, so then if that's how much they weigh, we can subtract the vendor's guess, and because we're looking for absolute value, whether this is bigger or less won't really matter. We'll still know how off they are. Hey, that matches this one right here. Awesome. Opposites. If A and B are real numbers and A does not equal B, then the difference, A minus B, is the opposite of B minus A. The absolute value of opposites are always equal. All right. Evaluate an absolute value of an algebraic expression. All right, let's take a look here. From step 1 to step 2, what has changed? We use substitution. Got it. Then from step 2 to step 3, let's see, it says we multiplied, so 5 and negative 3 became negative 15, all right. Negative 2 and 6 make negative 12. Negative 12 and negative 3 make positive 36. 36 minus 15 gives us 21. And the absolute value of the difference is just 21. Check. Evaluate the following if A is negative 2 and B is negative 3. Okay. Now, anytime they give you absolute value symbols, think of them like grouping symbols, just like parentheses. Ooh, we have a negative out in front. That's going to affect this whole thing. 5, and instead of A, we're going to write negative 2, because A is negative 2, plus 3, parenthesis, 2, and we're doing some more substitution. So we have another 2 again, so that's going to be negative 2. And we have a B equals 3, so we got to plug that in as well. Negative 3. Then let's see, after that, minus 1, parenthesis, absolute value symbol. Now, when we have embedded absolutes in parentheses, it's always nice to mark them. So here's the absolute. This counts as a grouping symbol. And here's our set of parentheses, which have grouped things. So we should start with our purple parentheses and get that evaluated before we move outward to the absolute value. All right. 2 times negative 2 is negative 4. Negative 4 times negative 3 makes positive 12, minus 1 is 11. All right, so all of this, and then we're multiplying it by 3. So this becomes 33. So all of this goes down to 33. Negative 2 times 5 is negative 10. And absolute value, and the negative. All right, negative 10 plus 33 gives us 23. The absolute of 23 is just 23. That negative out front makes it a negative. So negative 23. The only way for a negative to come out of an absolute value is to have that negative out in front. Because no matter what happens in here, it spits out a positive number. That negative will always apply and change it. Think about it. How would you evaluate the expression absolute negative 2 times xy plus 5y? Well, first we'd simplify it with distribution. So we have our absolute value symbols. If I do this, we get negative 2xy minus, not 5, this should be 10y. And honestly, we can then split this into 2 parts because it could equal a positive or a negative, but we don't really have a value. So after we do the distribution, I'd say we just, honestly, we have to leave it. X, Y, and Y are not like terms. So it's just the absolute value of their difference. And we don't really know anything beyond this. Example 3. Evaluate an expression involving absolute value. When evaluating algebraic expressions, absolute value bars act as grouping symbols. Perform any operation inside the absolute value bars first. Hey, that's just what we talked about. Study tip, apply the order of operations when evaluating expressions inside grouping symbols. Before all the multiplication from left to right, and then do the addition and subtraction from right to left. Honestly, I like thinking of order of operations kind of like the stack on Magic. If you've ever played Magic, they have this thing called the stack, and it is how abilities go off when you play cards. Order of operations is a lot like that. There are priorities, certain things happen first, and if you get your head wrapped around it that way, solving an equation is more like a game following the rules. For this one, they're giving us a statement. 23 minus the absolute value of the sum of 3 and 4x if x equals 2. All right. So first off, from our initial statement, what's changed? Well, from here to here, the x became a 2, so that was substitution. All right, from here to here, 4 times 2 was done to become 8. That's multiply. From here to here, we see that they did addition. From here to here, we saw they evaluated the absolute value. And then from here to here, they did subtraction. Additive inverse, although absolute -2 is equal to absolute 2, replacing x with -2 will not give the same value as replacing x with 2. The evaluation of the expression will be the same only if 3 plus 4x equals -11 for some other value of x. So they're just asking us to watch out, make sure that we're plugging in the right values. Evaluate 1.4 minus 2.5 times the quantity of 5y plus 0.6 if y equals -3. All right, we're going to need some room for this. So we have 1.4 minus 2.5. Gotta love it when they add decimals in. We have 5. Plugging in a value of y, let's use that -3. Plus 0.6. First thing we're going to have to do is take care of everything inside this absolute value. 5 and -3 make -15 plus 0.6. -15 and 0.6 should make -14.4. The absolute value of 14.4 is just positive 14.4. So now we have 1.4 minus 2.5, 14.4. Give me 1 second. Grab the calculator. From here, this is easiest, just do left to right on a calculator. We have 1.4 minus 2.5 times 14.4, -34.6. And that matches A. All right, in a couple moments, we'll be right back. And we will start off with the homework. See you then.